Higher Maths straight line topic, lesson number 10. We're going to look at the intersection of medians, altitudes, and perpendicular bisectors and how to find that point of intersection. First of all, a few definitions. If we look at the three perpendicular bisectors of a triangle, they all meet at the same point. Quite interesting fact. That point is called the circumcenter. The point of intersection of the altitudes of a triangle. Again, all the altitudes intersect at the same point. It's called the orthocenter. And the centroid is the point of intersection of the three medians of a triangle. Right. Example, this is an exam type question, probably worth 9 or 10 marks. Find the point of intersection of the altitude QT and median PS. Right, to do that, first of all, we need to find the equation of altitude QT. So how we're going to go about doing that? Well, it's an altitude. We know an altitude is perpendicular to the opposite side and passes through this corner here, Q. So I'd find the gradient of PR. So again, y2 minus y1 over x2 minus x1 minus 14 over 7, which is negative 2. So to find the perpendicular gradient, we flip that. So the gradient will be half, and it passes through Q. Again, I'm using Q because Q is on the line. Q is on the altitude. Very important. Pick a point that is on the line. So y minus b equals mx minus a. Careful minus signs. Y subtract negative 2 equals a half bracket x subtract negative 12 bracket. Don't want to multiply out and get fractions, so bring the 2 up, 2 bracket y plus 2, so 2y plus 4 equals x plus 12. Take the 4 over to the other side, 2y equals x plus 8. So we have the equation of QT, the altitude. We're now going to try and find the equation of PS, the median from P. So quick look back. I need to find, so finding the median, what do we need to do? We need to find the midpoint, then find the gradient of PS, then use that gradient, because we're not using a perpendicular gradient there, so use a gradient of PS and the point, either P, or we could use a point S if we want to. So first of all, to find the midpoint, we need to find the middle of QR. So I know Q is negative 12, 12, R is 8, negative 6. Again, we're just looking for the middle of the x coordinate. So right in the middle of negative 12 and 8, we have negative 2. And the middle of the y coordinate, right in the middle of negative 2, negative 6, we have negative 4. So the midpoint will be negative 2, comma negative 4. And remember, P is at 1, comma 8. There it is up there. So now we're going to find the gradient of MP, or PM as I've called it. So substitute in y2 minus y1 over x2 minus x1, which comes to 12/3, which is 4 wholes. Again, guys, we're using the actual gradient here, not the perpendicular one. Substitute in. I'm going to use 1/8 as my points here because they're both positive. So y minus 8 equals 4 bracket x minus 1. So multiply out the bracket, 4x minus 4, take over the minus 8, it becomes positive, or we're really adding 8 to both sides. So y equals 4x plus 4 once we've tidied up. Right, point of intersection, let's have a quick look back. If I have the equation of both of these lines to find the point of intersection, I use simultaneous equations, so another step back to National 5. Simultaneous equations, we use simultaneous equations to find the intersection of two lines. So here 2y equals x plus 8, here y equals 4x plus 4. So column 1 and 2, because the examiner and me and anybody else looking at your work needs to know exactly what you're doing when you're solving these. So I have chosen to double equation 1 to make the coefficients of y, the amounts of y, equal. So double this, we get 2y equals x plus 8. I'm now going to subtract equation 2 from equation 3. So 2y subtract 2y is nothing. 8x subtract x is 7x. 8 subtract 8 is 0. So I have 7x is equal 0. 7 somethings are nothing. So the x has to be nothing. Or if you want to divide through by 7, x is 0 divided by 7, which is 0. So the x coordinate's 0. Substitute into either a or b, or sorry, 1 or 2, to find the y coordinate. So substitute into 1, y equals 4 zeros plus 4, so y equals 4. There we go. So the point of intersection, we know the x coordinate's 0, the y coordinate's 4. The point of intersection is 0, 4. So again, with an exam question, you're quite often asked to find the altitude of one and the median of the other, or maybe the perpendicular bisector. So you'd find one, you'd find the other one, and then for the last 3 marks, simultaneous equations to find the point of intersection. Right, have a go at exercise 1N.